So for the first part of this experiment, we will be preparing a saturated solution of calcium iodate. In order to do that, we will weigh out about 50 milliliters of potassium iodate, that's KiO3. So you want to measure out 50 milliliters. This tube holds 50 milliliters, so I'm just going to go ahead and pour it into this beaker. So the potassium iodate, KiO3, is a source of IO3 minus. So let's just pour that in there. All right, calcium iodate is what we're making. So we just added the potassium iodate. And now for our source of calcium, we'll use calcium nitrate. And the protocol asks for 20 ml, so I'm going to weigh out 20 milliliters here. So let's isolate this precipitate. I'm going to take this filter paper. Okay, so we already know how to do this from Chem 1. It's just a review here. So I'm going to fold it in a half, and then another half. Just keep on folding it. And the more divisions you get, the better filtration you'll get as well. Here's our funnel. It's attached to an Erlenmeyer flask. And let's just affix this to our funnel, our glass funnel. And to get it to stick, I'm going to wet it with some DI water. So your partner can help you with this. Let's let that go in here. Okay, wet it a little bit. Okay, here's our precipitate. And let's just dump it in. Letting it, don't want to overflow it here, and let's get our spatula, or excuse me, our stirring rod, and get all of that precipitate out into our filter paper. We will collect this precipitate into this filter paper, okay, and we'll probably wait a good portion of time, probably around 30 minutes or so according to the protocol, but we want to get everything that's sort of out here. Okay, so I'm also going to wash this here. And my white calcium iodate solid is now onto the filter paper. And the filtrate, which is the thing at the bottom, should have calcium ion and iodate ions, and up on top should be my solid calcium iodate. Okay, so we really didn't have to wait 30 minutes. As you can see here, the precipitate is as dry as it could be. Could be a little bit more dry, but that's okay. I'm going to go ahead and follow the next step in our protocol. So here's our white calcium iodate. We're going to split it into a third. So I got my spatula here. So you can be just kind of, you should be careful, but at the same time, it doesn't have to be exactly 1/3, 1/3, and 1/3. So I'm going to split it maybe here, and then maybe here. Okay. So take a little bit of this, okay, so about 1/3 of it, and put it into a beaker. Okay, here's my solid calcium iodate. I'll take another third here. So you may rip the filter paper. That's okay. I try not to. Take another third, and again, this is very much approximate. Okay? And then put it into our second beaker over here. Let me get all of that in there. Okay, so whatever is left over can be just for practice, or in case this fails, you have still that leftover 1/3. So here's my calcium iodate solid. It's going to go into 2 beakers. One of these beakers, we will put 80 milliliters of water. So remember, we have solid calcium iodate. We put 80 milliliters of water in. So now, because calcium iodate is a sparingly soluble solid In the solution, you'll have calcium ions and iodate ions, Ca+2 and IO3-. In this beaker, we'll put 40 milliliters of water. So we'll still get a precipitate here. One thing we want to do is get our stirring rods and stir them. So you're going to need 2 stirring rods here. Keep the stirring rods inside, give it a good stir. And here, the protocol tells us to wait 30 minutes, and I think you should really wait 30 minutes here because you want this to start to precipitate. And as you will see it precipitate here, you're also going to see the liquid portion have your calcium ions and iodate ions. So now we will wait 30 minutes and we will move on to the standardization part of this experiment. All right, so before we begin our titration, we'll do a little pre-cleanup of our burette. So I've got my funnel here. I already preloaded it with some water. So a good way to clean a burette is to just, got some clean deionized water. We'll just tip it and circle it like this. Okay, so you can do that a couple of times. I'm only going to do it once. And then we'll coat it with our titrant. Our titrant here is sodium thiosulfate. I already have about 20 milliliters here, according to the protocol. So let's just put the funnel in here. This is 20 milliliters of S2O3, or sodium thiosulfate. Just kind of coating this, coating the burette, getting it pre-clean before we actually do the standardization experiment, of the sodium thiosulfate. All right, so we'll do that one time. You can do it a couple of times, it will not hurt. We're going to use a lot of sodium thiosulfate. And now we'll do our actual experiment where we will fill it up all the way to 50 milliliters and then begin our titration. So the next part of this experiment is standardizing the sodium thiosulfate solution. So in order to do that, we will standardize it with this iodate solution. We need to not just iodate, we got to do a couple of other things here. So let's prepare, this is called the titration, so that's the flask. And so the first thing we'll do is we will put in, we got to put in all these chemicals. The first thing we'll put in is 10 milliliters of the potassium iodate, so 10 mLs. So we're going to pipette that in with our glass pipette. All right, so just be patient and be careful when you're pipetting. All right, so we got about 10 mLs of the KiO3 potassium iodate, so we'll put that in here. So that's not all that's going to go into our flask. Remember, the flask is also known as our titrand. The thing that we put in the long burette is called the titrant. All right, so that's 10 mLs of potassium iodate. Okay, make sure you use the one that's 0.01 molar, okay, not the other concentrated one. Okay, that is in our 120 milliliter Erlenmeyer flask. The next one is 20 mils of deionized water. So I already have some deionized water here. Next thing is we're going to put in about 1 centimeter cubed of this Ki potassium iodide solid, So we don't have to be too terribly accurate. 1 centimeter cubed is about 1 ml. So we'll take a spatula and guesstimate 1 ml. So that's about the 1 ml mark here on a graduated cylinder. Maybe a couple of pea-size portions here. Okay, I'll add a little bit more. Okay. You want to get it to the 1 ml mark, roughly. All right, so about 1 mils or cubic centimeter of solid Ki. So that's also going to go in here. So about the 1 ml mark. Again, you don't have to be so exact with this solid. It really is just a catalyst and helps give the color. And then finally, we're going to acidify this with 20 drops of HCl. 2 molar HCl. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 20 mLs, 20 drops of 2 molar HCl. All right, so our solution, titrant, is ready. Okay, we can already put this in here, and we will fill up our titrant. Okay, our titrant here is our sodium thiosulfate. So let's get our funnel in there. Let's just remove this temporarily. And I like to, whenever I do my titrations, I like to fill it up all the way to the top. It's just very easy to measure how much goes in when you start off at 0.00. Remember, you want to read this to 2 decimal places. I'm going to slowly fill that to the top 0.00 line. If you overflow it, you can remove it with a waste flask. And I think I got it here. Remember, you read that to 2 decimal places. Okay, you read it, you're at to 2 decimal places. So right now I have it at 0.00. Whenever you record your data, your numbers, read it. What you put down in your lab notebook in your data sheet is the volume to 2 decimal places. So you make sure you guesstimate that 3rd digit. So now we are ready to start our titrations. All right, so before we begin, I just put a piece of white paper here underneath the flask. And the protocol says that instead of going drop by drop by drop, we're going to let this flush, and we'll let it flush to 2 milliliters before our pre-lab calculations. So the equivalence point is roughly about 24 milliliters. Again, we got that from our pre-lab calculations. So I'm not going to let this go all the way to 24. I'll let it go to 22, and then after 22, we'll put some starch in, and then we'll go drop by drop. So I'm going to let this go down, and I'm checking my volume to make sure it's going to stop at around 22, and it's a little bit. All right, now the volume level is roughly around 22 milliliters. All right, so now we're going to go drop by drop now. Before we do that, I'm going to add some starch, just another indicator here.
All right, so about 40 drops of starch, and then we will start our titration. 40 drops here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, and 40.
All right, so now we're going to go drop by drop. I'm probably going to go maybe at around 0.5 mils at a time until this turns colorless. Okay, once this turns colorless, all of the sodium thiosulfate in my burette, reacted with all the IO3 minus iodate in my flask. And the color change is facilitated by the HCl, the potassium iodide, and all of that stuff. Okay, so let's go ahead and do this maybe 0.5 at a time. Okay, so you have to really be patient here. So just when it turns colorless. All right. Yeah, it took a little while, more than I thought it would be. Maybe I overshot it by a little bit. Let me read the number and then I'll rotate it here. I am getting about, my reading is about 38.70 ml. So let me just rotate it here. It may be hard to see for those of you that are doing this virtually. You can try to put a dark background, but it's about 38.70. Again, notice I'm reading it to 2 decimal places, so I'm saying that's 38.70. You can say 38.80, or everybody's eye and everybody's visual acuity is different, but I'm calling that 38.70. We're going to record that in our data sheet. The initial reading was 0.00. All right, so trial number 2, we want to make sure that this second titration agrees with the first titration numbers. And so it's actually just a duplicate. Once again, I have my burette initial reading at 0.00, so I've just filled it up to the top. And I'm going to let this go down all the way to about 22 milliliters. All right, so we're going to go to 22. My first one I got 38, so probably it's going to take a while for it to get to 38. Hopefully there's some reproducibility. Once I get down to 22, don't forget to add your starch. So we want to add about 40 drops of starch to get that into a blue color. Again, this is the second of our duplicate. Just testing for reproducibility here, 40 drops. And just like last time, I'm going to go, this time I'm probably going to go 1 ml at a time. Have a general idea now. I'm looking at around 38 or so. Your data will be a little bit different than my data. Your numbers may be different for those of you that are doing the lab in person. All right, I'm at 36 mLs. I'm just going to go a half ml now, 0.5 mLs. Hopefully I'm getting somewhere close to 38. All right, let me go down and just read this out here to myself. I'm getting around, actually I'm getting close to 38.6, 38.7. Okay, I'm pretty good here in terms of reproducibility. That always makes, by my eye, at around 38.7. I actually, you can even say 38.6, 38.7, 38.70. Okay, I'm calling that 38.70. You may call it 38.72, 38.73. That's fine. Everyone's eyesight is different, but I'm going to go with 38.70. It's very reproducible with my first trial. I'm going to note that in my lab data sheet, and we will move on to the next part of the experiment. So this part of the experiment, we will be analyzing the saturated solution of calcium iodate. The purpose here is to figure out solubility S of the iodate. In turn, you can also get the solubility S of the calcium ion. So remember, in the earlier part of the experiment, we had the calcium iodate precipitate. We put one part in 80 mils of water and another part in 40 mils of water. It's very important at this part of the experiment, the analyzing the saturated solution calcium iodate part of this experiment, that you'd want to keep everything as dry as possible. So I'm going to take the 80 milliliters of water that we dissolved the calcium iodate in and put it in a dry filter paper. Okay, just do it very slowly here. You can use a flask or you can use a beaker. The idea is that this filtrate contains calcium ion and iodate ion, so we're going to proceed with the titration. We'll do 4 titrations. I'll explain more about that later. Let me just finish up pouring the rest of this in. Okay, we're really interested in the bottom part here. Again, it's called the filtrate, and it contains our calcium ions in water, dissolved in water, and our iodate ions, IO3 minus, dissolved in water. So let's just do this for the 80 mil, the precipitate that was in 80 mils of water. Slowly filter. We'll do the exact same thing for the precipitate that was put in 40 mils of water. Remember, we split that precipitate 1/3, 1/3, 1/3. So let's just do that here. Okay, we don't want to wet anything. We want to keep things dry as possible for this stage of the titration. So let me pour all of this in here before I explain about the types of titrations that you'll be doing. You'll be doing 4 titration. Our filter should capture the calcium iodate precipitate, but we're not concerning ourselves with that. We're concerning ourselves with what's at the bottom here, the filtrate, again, which contains calcium ions and iodate ions. And we will do 4 titrations. So this will have a trial titration where you'll guesstimate the sodium thiosulfate that will react. And then after that, you'll do an exact titration. Same thing over here. We will do a trial titration, guess how much sodium thiosulfate will react with all the IO3 minus here. Same titration that we did before. And then following the trial titration, we will do an exact titration, sort of getting the exact volume of the sodium thiosulfate that's in our burette will react with the IO3 minus that's in here, our filtrate. So 4 titrations in all to complete this experiment. A trial titration and then an exact titration, and then the same thing here, a trial titration and an exact. So we're ready to proceed with our titrations with the filtrate. So first thing here, the lab manual makes an important point that everything should be dry and clean. So first thing is I'm just going to clean this glass pipette with some water. Just a little bit, I'm just squirting it in there from the top. Let that go. Right, just a little bit of swings to try to dry out or shake out the water. Just shaking it out. All right, now we're going to use our filtrate here. We got the 80 mils and then the 40 mils. Let's just go with the 80 mils. Remember, we're going to do a trial titration and then an exact titration. Same thing with the 40 mils. Remember, this has 80 mils of water into that precipitate. This has 40 mils of water in that precipitate. So let's just pre-coat this with some of this filtrate. Just coating it so that it sort of gets rid of all the water. So this is just a clean. Alright, so the protocol says about 2 mils. So you can guesstimate 2 mils. That's probably more than 2 mils. And then just coat this. Right, try not to get the liquid to the top, otherwise that's really going to mess up your sort of coating this in. Again, don't get the liquid up here to the top. Alright, so we've coated this and we're going to start our titration now. Alright, this is our trial titration. So 10 mils of the filtrate. 10 mils of the filtrate. Alright, so here's 10 mils of the filtrate. And same thing as before. Okay, so 20 mils of water, about 1 milliliter of that solid potassium iodide or Ki, and then 20 drops of the HCl. So let's go ahead and pour these in, and then we can start our titration. Alright, this is going to be our trial titration. That's the 20 mils of water. Here's some Ki, solid potassium iodide. And then 20 drops of the HCl. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So next, according to the protocol, we will add 40 drops of the starch. So let's go ahead and add 40 drops of the starch here. Adding the 40 drops of the starch should make it turn blue. And we're going to titrate this with the sodium thiosulfate S2O3 till it turns colorless. All right, so here's our first trial titration of an 80 milliliters. The precipitate was put in 80 milliliters of water. This is a saturated solution. Once again, as a review, here is my IO3 minus. That is my titrand. This is part of the filtrate. We added some starch, water, and some acid, and Ki solid. And I already filled my burette, my titrant, with sodium thiosulfate, right? Na2S2O3. So this is in my burette. And the volume markings are facing me. In the trial titration, I'm just going to go 1 ml at a time. 1 ml at a time. And then my second exact titration, I can get a little bit more exact. So here we go. May take a little while, so if you're doing this lab in person, you definitely want to exhibit some patience here. But I'm going to go 1 ml at a time. I'm going to try to go a little bit fast here. Okay, realizing that this is just my trial titration. All right, so it didn't take that long as I expected. It turned colorless. Let me read the markings and then I'll switch the burette over. I'm getting around almost exactly 12 milliliters. So I'm going to call that 12.00. If the brown background helps, but I'm calling it 12.00. And I'm going to write that down in my notebook and as well as my lab worksheet for the trial titration. All right, so that was our trial titration, which was about 12 milliliters. I recorded it down, but I'm not going to record the actual value because in my exact titration, that's when I'll record my actual value of my burette readings. And let me tell you what that means. So in our first titration, we got about 12 mils. And so what I'm going to do is going to let this go up to about 10. Maybe about 9 mils, and then I'm going to go 0.5 milliliters at a time. All right, so my first trial titration, I got 12 milliliters. I'm going to let this go down to a volume of about 9 mils, and then I'm going to go very slowly, half mil by half mil. Okay. So I already filled this up to 0.00. I got it at 9 milliliters. Now I'm going to go half by half. All right, so here we go. Very, very slow. All right, here we go. So let me read that here. I'm getting about 11.49 milliliters. All right, 11.49 milliliters. Let me zoom in on that. The important point is you want to get that last two, you want to get 2 decimal places. Okay, so I'm calling that 11.48 or 11.49, and that is what I'm going to report. For my exact titration, this is from the 80 ml filtrate, and now we've got 2 more titrations to go with the 40 milliliter filtrate. All right, now we will do our trial titration. This is a trial titration of the precipitate that was put in 40 milliliters of water. And don't forget, we added all the other stuff here as well, the water, the HCl, some starch, and then the solid potassium iodide Ki. Trial titration, I'm going to go pretty fast, 1 ml at a time. And you got to be patient here and also watch the change in color. So 1 ml at a time. I'm going to call that 17.23 milliliters. So let volume around and see if Larissa, the camera person, can see, zoom in on that. 17.23, that's what I'm going to call that. Again, it's very important for those of you that are doing the lab in person that you read the burette to 2 decimal places. So 17.2. Get that get that other digit in, so I'm guessing that to be 17.23 milliliters. This is our trial titration. Now we will do our exact titration. I'm going to fill that all the way to 0.00, let it go down to about 14 or so, and then at 14 I'm going to go very, very, very slowly. For right now, my trial titration is about 17.23 milliliters of thiosulfate. All right, now let's do our exact titration. In my trial titration, I got about 17.23 milliliters. So I'm going to let this go all the way down to about 14. Let's say 14, and then after 14, yeah, I'm going to go really slow, drop by drop, half mil at a time. So let's just let this go down all the way to 14 mLs. And that is 14. All right, now we're going to go really slow. All right, so I'm going to go about half a mil at a time. All right, so let's read this number here. I'm getting something a little bit higher than I got before, so maybe the trial titration was a little bit too fast. But I did this a little bit more carefully, drop by drop. So this, I'm getting about 18.20. So I kind of, when I was at 17, I went very, very slow, drop by drop, and it turned colorless here at this volume, 18.20. So that is our exact titration, 18.20. It's around there. Remember, what does that signify? It signifies that all of this thiosulfate, sodium thiosulfate, 18.20 mils of sodium thiosulfate reacted, its concentration is 0.025 molar, reacted with all the IO3 minus that was in my filtrate. Okay, that is what we call the equivalence point.